In this question, we're given a parametric surface. R of uv equals u sine 3v, and u cosine 3v. And we want to write this in rectangular form. And so right away, when I see a sine and a cosine, I'm thinking of using my favorite trig identity. Hopefully it's your favorite too. What's your favorite trig identity?
Sine squared plus cosine.
Okay, so cosine squared theta plus sine squared theta equals 1. So, okay, I know that this u is going to be my x, right? So I can just replace u with x, but I'm not interested in doing that right now. Really what I'm interested in what y and z are equal to. Because the idea is this: to go from parametric to rectangular, I think it would be helpful then to kind of think of this identity and square the y and square the z and see where that leaves me. So I don't think it'll get rid of everything, but let's see what it does. So y squared plus z squared, what is that in terms of u and v then? So that would be u sine 3v, the whole thing squared, right? That's the y squared, plus u cosine 3v, the whole thing squared. That's the z squared. And of course, well, I think we can do more than one step at a time here, right? So that those exponents apply to both factors in both products. So that's u squared sine squared 3v plus u squared cosine squared 3v. I can factor out that u squared. Is it okay if I do all that in one step? And then that leaves me with essentially 1 in the form of sine squared 3v plus cosine squared 3v, right? So that leaves me with u squared times 1, or just u squared. You might think, oh no, we haven't gotten rid of the u yet. But what do we know u is equal to? X. So we've got, let me write it the other way around. Well, I'll write it this way first. Y squared plus z squared equals x squared. Actually, that's a good way to leave it. But then we should be able to identify it, right? What is that thing? It's a cone. Which axis would be the central axis of that cone? Be the x-axis, right? Yeah. So there you go.